Hello students, myself Vikas Tiwari. Once again, I welcome you to channel MAP World of Physics. As I have already told you in the very first lecture that we are going with the topic of electrostatics of class 12th. Okay, so that is the very first topic of class 12th as a revision for the board exams. Just I have already discussed with the concepts of electrostatics, means the definition, what is the definition of electrostatics and what is frictional electricity, and after that what is the inherent property of an object. Okay, like charge is an inherent property of any object, any body, that we have already discussed. What is charge, definition of charge, and what are the properties of charge. Okay, in that context just I am moving further with some more things that I want to discuss over here. So let us go with what is the dimensional formula for charge. Okay, so as we know that what is charge. Okay, what is current? Electric current is defined as charge per unit time. Just to find out the dimensional formula, I am telling you the definition of the current is, because electric current is considered to be a fundamental quantity. Okay, so that's why I is equal to q upon t. From here just I will say what is the value of charge is considered as I into t. So just I am deriving, this is charge is some derived property. Okay, physical quantity in terms of fundamental quantity. Okay, so I can say that current is written in ampere. Okay, and time is already in seconds. Okay, based on this, what is the dimensional formula for charge? I can write, there is no terms of mass, fundamental quantity m0. Okay, L0. Okay, there is no fundamental quantity of length in this particular formula. Here just I am writing ampere, and time is t raised 1, and so this is the dimensional formula for the charge. Okay, after that writing this, just what I am saying, what is the units of charge. Okay, so the basic unit, if I will say in MKS unit or SI unit system, when I am talking of units of charge in MKS or SI system, in MKS or SI system, okay, the unit of charge is given as coulomb. Okay, so this is the unit of charge in, and it can be written just, it can be represented as C. Okay, so this is the unit of charge in SI system or in MKS system. If I am talking, if I am saying what is the unit of charge in CGS system. Okay, in CGS system the unit of charge is considered as ESU. It can be written as ESU, and it can be termed as electrostatics unit. Electrostatics unit, or it can also termed as state coulomb also. It can also be written as state coulomb. Okay, so this is these are the two units of charge in MKS system and in CGS system. And what is the relation between, coulomb and ESU? 1 coulomb is equal to 10 raised to power 9, 3 into 10 raised to power 3 into 10 raised to power 9. It can be written as 3 into 10 raised to power 9 ESU. Okay, so this is the relation between coulomb and ESU. Okay, there is one more bigger unit, and that can be considered as farad. Okay, so 1 farad is equal to 96,500 coulomb. So this is the biggest unit, okay, in terms of magnitude for charge. So these are the basic 3 units which can be generally used for the charges, that is MKS unit coulomb, CGS unit ESU, This is the relation between Coulomb and ESU, and another bigger biggest unit is Farad, and that can be written as 1 Farad is equal to 96,500 Coulomb. So this is about the dimensional formula and units of charge. Okay, now I want to just discuss with some of the formula, some of the numericals over here which are based on the quantization of charge. So just to discuss all those formulas over here. Okay, so just I am taking very first question, that is calculate number of electrons in 1 Coulomb of charge. What are the number of electrons in 1 Coulomb charge? For that particular thing, just I am going to solve this numerical. As from the quantization of charge, as I have already told you what is quantization of charge. Quantization of charge is meaning is that the minimum value of charge has been fixed, electronic charge has been fixed to 1.6 into 10 raised to power minus 19. Okay, and the charge can be transferred from one body to another body in its integer form only. Okay, means either one charge, either 2 electrons, or either 3 electrons, or either 4 electrons, that will be transferred from one body to another body, not its fractional value. Okay, so like that, if I say what is quantization of charge, so this is the answer for this first question I am writing. Just I am solving this particular question. As we know that as Q is equal to N into E. Okay, so it is asking what is the calculate the number of electrons in 1 Coulomb of charge. So as we know that electronic charge, the magnitude of electronic charge is equal to 10 raised to power minus 19. Okay, so here the value of Q is given to 1 Coulomb. Okay, and we have to find the number of electrons, that is N, and it can be written as Q upon E. Okay, so the value of Q is equal to 1 Coulomb and value of electronic charge is 1.6 into 10 raised to power minus 19. Okay, so the way we can solve it as 10 upon 16 into 10 raised to power 19, or I can write 100 upon 16 into 10 raised to power 18. Okay, so if I will solve this, so it will become 6.25 into 10 raised to power 18. So these are the number of electrons present in 1 Coulomb of charge. So this is the explanation of very first question. Calculate number of electrons in Coulomb of charge. So you can write the number of charge in 1 Coulomb is equal to 6.25 into 10 raised to power 18. Okay, so if we'll move to the second question. What is the second question? If 100 electrons are shifted from a glass rod, then calculate the amount of charge produced in it. Okay, so here if we'll say what are the parameters already given in the question, the parameters that are given is equal to number of electrons. Number of electrons are 100. Okay, and it is asking what is the amount of charge, means what is the magnitude of charge produced in it. So as we know that Q is equal to N into E, so based on that N is equal to, in all of you we know that electronic charge is 1.6 into 10 raised to power minus 19. So we can say N is equal to 100 and value of this one is equal to 1.6 into 10 raised to power minus 19. So by solving this particular thing, we will say that the value of this particular is equal to 1.6 into 10 raised to power minus 17 Coulomb. So this is the answer for this second question. Okay, now what will be the value of what will be the answer for third question? Third question is here, can an object has 4.2 into minus 18 Coulomb of charge? And we have to justify our answer. Any object, is it possible that any object can hold this amount of charge? As we know that quantization of charge follows quantization. So based on that particular thing, we will say that Q is equal to N into E. Okay, so we have to find out the value of number of electrons. This value of n should be an integer value. If it is integer value, then this amount of charge is valid, and if it is not this integer value, then this amount of charge is not possible. So what we will say, n is equal to q by e. So q is already given in the question, and it is equal to 4.2 into 10 raised to power minus 18 coulomb divided by 1.6 into 10 raised to power minus 19. So it will become around, it is minus 19. So I can write minus 19. So it will become 42 upon 16. Okay, into 10 raised to power 1. Okay, if we'll solve these two values, it will become 10 raised to power 1, and if I will divide this one, so it will around 2.62 into 10 raised to power 1, which can further written as 26.2. So the value of this n is not an integer value. So we can say that this charge is not possible on that particular body, on that particular object. Okay, if this value, if we are solving and this value of n becomes some integer value, then we can justify, yes, this value is possible. But now, right now we are finding that it is around something around 26.2, which is not an integer value. Okay, so we can say it is not at all possible. Okay, so this is the explanation of third question. Okay, just now I am giving a one question for you just to try as an assignment. And what is the estimate number of electrons in 100 gram of water? If I will take 100 gram of water, then what are the number of electrons are present in that particular quantity? Okay, so just try it. Okay, what is, and just I will discuss this question in my next lecture. Okay, and I will come with a new topic for this electrostatics. Okay, so thank you very much.